Hi to all. Today's topic is force between two parallel current carrying conductors. There are two parallel current carrying conductors in this and in this. Current is flowing. Then in between these two current carrying conductors there is some force. That force on what factors it depends and what is the formula to find out the force that I am going to explain today. Okay, and listen very carefully. That is, first of all, let us take these are the two wires, infinite straight wires, and they are parallel to each other and carrying the currents I1 and I2, and the separation between the two wires is smaller. Now what, due to first conductor around the current carrying conductor magnetic field will be produces. For example, this is a first current carrying conductor. Around this magnetic field will be produces. According to the right hand thumb rule, if the current is upward, look at here, this pinpoint is the upward direction current, then the field this side inward, thumb shows the direction of the current, curved fingers indicates the magnetic field this side inward and this side outward. Look at here, fingers entering this side and this side coming outward. That means this side the field is inward and this side outward. Similarly here, due to this first conductor, around the current carrying conductor magnetic field will produces, right? Then B1 is the magnetic field produced by the first conductor. Okay, right. Magnetic field at a distance smaller due to first conductor, that is B1. What is the formula for the B1? Okay, at a distance r I want to find out the magnetic field. Okay, this is the I1 current carrying conductor. This right side field is inward. Okay, like this. Thumb shows the direction of the current. Curved fingers are entering this side, then the field is inward. Then B1 formula, field at a distance r due to infinite straight charged wire, we already discussed, we derived that one. That is nu naught I by 2 pi r. But here we know the formula, magnetic induction due to infinite straight current carrying wire, nu naught I by 2 pi r. In this, current I is I1 and due to first conductor the field, okay, that is B1 nu naught I1 by 2 pi r. Now first conductor produces the magnetic field around it, but this is the magnetic field direction, the cross B1 is the magnetic field due to first conductor, right? In this B1 magnetic field, the second conductor is there. Due to that, the force will act on the second conductor, right? Now I am going to write the force on second conductor. Okay? It is in the field of first conductor, right? It is in the field of first conductor. The second conductor, it is in the field of first conductor. Now what is the formula for the force on second conductor? That is the force on a current carrying conductor. Whenever a current carrying conductor is in the magnetic field, on that force will act. That force formula already we derived. That is ILB sin theta, right? And here force on second conductor I am taking it as F2. Its formula is ILB sin theta. Okay, what is theta at here? Angle between the L and B. L is the length of the conductor like this there. Field is inward at here, right? Second conductor is in the field of B1. Field is inward. That's why we have to take theta as 90 degree. Because L perpendicular to B. Okay. Then what is the current in the second conductor? I2. What is the length of the conductor? We can consider as L. And force on L length I want to find out. Then here we will get L. B is the magnetic field, but this I2 conductor is in the field of first conductor, that's well B1 we can write. Okay, the second conductor is in the field of first conductor, that's well here we have to write I2 L B1. This I2 conductor is in the field of B1, then we can write like this. And now we have to simplify this and we will get the formula for the force. Now it was very simple. Let us continue. Listen very carefully. This is very important for the exam. You see, and F2 is equal, we will get as I2 L into B1 formula is what? B1 formula from equation 1 we write. This is considered as equation 1. Okay. And I2, B1 formula is nu naught I1 by 2 pi R we write. This is the formula for B1. B1 is equal formula nu naught I1 by 2 pi R. Okay. I2 L B1. This we can write simply. The force on the second conductor is mu naught I1 I2 by 2 pi R into L. This is equation 2. This is the formula for the force on second conductor. Okay, what is the direction of the force? For that we have to use the Fleming left hand rule. The second conductor is in the magnetic field of first conductor. Due to that, the force will act on the second conductor. Then the force on second conductor we can find out by using Fleming left hand rule. Look at here the Fleming left hand rule, and you have to stretch the forefinger, central finger, thumb perpendicular to each other. You have to adjust the forefinger in the direction of the field. Okay, inward. Forefinger is inward, and central finger should be current. Then the thumb shows the left side. That means the force on this wire will be left side. Force on this wire will be left side. This is the force on second conductor. This is F2. F2 is the force on the second conductor. Force on second conductor is left side. Why it is left side? Because according to the Fleming left hand rule, the force is left side. Okay, right. Now force on first conductor also we have to find out. Okay, then this second conductor also produces the magnetic field around it. Then this side inward will be there. You have to hold the second conductor in the right hand in such a way that this side inward and this side outward. Then this side field outward will be there. Then the B2 is the magnetic field due to second conductor. Right? Magnetic field due to second conductor. Magnetic field at a distance R due to second conductor, that is B2. Then B2 formula is, I can write, okay, nu naught I2 by 2 pi R. This is equation 3. And then this first conductor is in the field of second conductor. Right, the force on first conductor. Force on first conductor. First conductor is in the magnetic field of second conductor. Second conductor is in the magnetic field of first conductor. That's why on both the conductors the force will act. Force on first conductor. It is in the field of magnetic field of second conductor, right? Second conductor. Now I want to find out the force on the second conductor, first conductor. That is, the formula is F1. Its formula is again ILB sine theta. Theta is again 90. This is the first conductor. Force on the first conductor I want. On the first conductor current is I1 and length is L we can take, and the field is B2 because this I1 conductor is in B2 field. Okay, and here L perpendicular to B, that's why we have to write theta is 90 degree. Then after that we have to substitute the values. F1 is equal, we will get as I1L, B2 is nu naught I2 by 2 pi R into L. Now we have to simplify this, okay. I1L, B2 formula I wrote it here. Then finally we will get as here okay. Let us see here. Now the F1 formula we can write here from here. Look at here very carefully. F1 is equal, what you will get from here. F1 is equal, we will get as, just rewrite these sentences, mu naught I1 I2 by 2 pi R into L. Okay, this nu naught I1 I2 by 2 pi R into L. This is force on first conductor formula. Force on first conductor, this is equation 4. This is the force on second conductor, equation 2. Okay, look at here. I want the direction of the force on first conductor. What is the direction of the force on first conductor? Okay, how to write the direction of the force on first conductor? For that, look at here. How to know the direction of force on first conductor? For that, we have to use the Fleming left hand rule. Now, forefinger is the field, thumb force, central finger current. Field is outward, right? The forefinger is outward. Current is upward. Current is upward. You have to adjust like this. Okay? Forefinger is outward. Forefinger. Central finger is the current. Then the force, when you apply the Fleming left hand rule, the force will be right side. That means the force on the first wire is right side. Okay, that means force on the second side left side, force on the second wire left side, force on the first wire right side. That means these two wires will attract with each other. If the two wires are parallel to each other, carrying the current in the same direction, then they are attract with each other. Let us continue. Now I am going to rub these all things and take the screenshot and note the notes. Now I am going to rub it and continue. Now from equation 2 and 4, force between two parallel conductors, we derived the formula. What you derived? From equation 2 and 3, we write one thing, right? From equation 2 and 3, the force formula, force between two parallel conductors formula is from equation 2 and equation 4. What we write? Tell me. That is the force between two parallel conductors formula we write. Force between two parallel conductors. Two parallel conductors. What is that force between two parallel conductors? We write that is F1 is equal to F2. This force is same. That is mu naught I1 I2 by we write 2 pi R into L we write. Okay. And now we have to take this F1 F2 as the 4 F is equal, we write as nu naught I1 I2 by 2 pi R into L. This is the force between two parallel conductors. Okay, this is equation 5. And force per unit length I want. Force per unit length. Force per unit length. Then how we write the force per unit length? That we write as mu naught I1 I2 by 2 pi R we write. Okay. Just L we have to take to left side. Now I want to define the ampere based on this formula. How to define the ampere definition? Okay. Now ampere side heading. Ampere. Right. Ampere is what? It is a unit of current. It is the unit of current. Now for that definition of ampere, if you want to write, I will take the two parallel conductors, carries the current in the same direction. Now I will take the current as 1 ampere. I want to define I1. Current in the first conductor we will take as I1, and current in the second conductor is I1, I2. Then I will take it as 1 ampere. Mu naught value we know 4 pi into 10 to the power of minus 7 Henry per meter, and R value I will take as 1 meter. Then substitute all these things and find the F by L. Then we will get as mu naught I1 I2 by 2 pi R. Now substitute all values. That is 4 pi into 10 to the power of minus 7 1 into 1. I1 is 1, I2 is 1. 2 pi into R is also 1. We will get here like this. The answer we will get is 2 into 10 to the power of minus 7 Newton per meter, force by length. That means if two parallel conductors carries the same current 1 ampere, okay, then if that two parallel conductors separated by 1 meter distance, the force per unit length will become 2 into 10 to the power of minus 7 Newton per meter. Then how to give the definition of 1 ampere based on this? Let us see here. This is very important, definition of 1 ampere also. One definition, okay, I am going to write the definition of 1 ampere. 1 ampere is the 1 ampere is the current through two parallel conductors separated by 1 meter distance, and force between them is how much force should be there? Force between them is 2 into 10 to the power of minus 7 Newton per meter. Okay. 1 ampere is the current through the two parallel conductors. Okay. So 1 ampere is the current through the two parallel conductors, 1 ampere and 1 ampere. When they are separated by 1 meter distance and the force between them is 2 into 10 to the power of minus 7 Newton per meter, then this is the definition of 1 ampere. Now let us go for some important points. Note, the important point is that if the two conductors carries the current in the same direction, I1 and I2, these two conductors are attracted with each other, right? What type of force will act between them? Attraction force will be there. Okay, currents are in same direction. Currents are in same direction. Then two conductors attract with each other. Two conductors attract with each other. Two conductors attract with each other. If the currents are in opposite direction, let us consider. This is the first one conductor carries the current upward. Second one conductor carries the current in downward. If the currents are in opposite direction, the currents are in opposite direction. If the currents are in opposite direction, then these are repel with each other. Repulsion force will act between them. Okay, two conductors repel with each other. Two conductors repel with each other. Okay, right. Now also you can take the screenshot and note the points. Then I will continue after rub. Okay, now I am going to explain some more points in the note regarding this. Okay, listen very carefully. Right, third point I am going to explain. Third point. What is this third point? In this I want to find out the force on certain current loop. Okay, right. Now force on a rectangular loop. I want to find out the force on rectangular loop. Look at here in following figure. In this following figure I want to find out the force on rectangular loop. How? This is a current carrying conductor. Okay, its length carries I1 current. It is infinite length, and there is a rectangular loop at here. This is a rectangular loop, right? This is A, B, C, A, B, C, D. Okay, look at here. The current starts from A, that is I2, and it goes like this, like this. This is I2, I2. And now I want the force on this rectangular loop, and this distance I will take as some A, and this distance I will take as B. Okay, and now I want to find out the force on this rectangular loop. First I will take the length of this rectangular loop. We can take as L. Okay, right. How to find out the force on this rectangular loop I will explain. Force of rectangular loop I want to find out. Little change I will tell that here the L is the length of the rectangular loop and B is considered as the breadth of the rectangular loop. Okay, breadth of the rectangular loop we will take as B. This is B, and the distance is, this distance is A. Now what about the force on the rectangular loop? What is L in this? L is length and B is the breadth. B is the breadth of rectangular loop. Okay, rectangular loop. Then how to find out the force? What about the direction of the force on AB loop? Right, this AB wire and this wire, current is in same direction, they are attracted with each other. That means this AB on AB wire, that the force is left side. On CD wire, the current is moving up, here down, means current is in opposite direction. The repulsion force will act F2, right? And which is more and which is less? What is the net force? And what about the force on BC? Force on BC. Force on BC direction is exactly upward will be there. How we know the direction of the force? Right? We have to use the Fleming left hand rule. Fleming left hand rule. What about the direction of the magnetic field at here? Inward, right side, due to this current carrying wire. Okay, this is around this current carrying wire, magnetic field will be produces. In this magnetic field, this loop is there. That's why the force will act on the loop. Now magnetic field at here is inward field, and magnetic field is inward. The current is right side on the BC loop. Then you have to use the Fleming left hand rule. First you have to arrange the forefinger in the direction of the field, inward. Current is right side, force is upward. That means the force on this loop is upward and force on this loop is downward. Okay, force on BC loop and force on BC loop we can take as F3. Force on AD loop we will take as F4. Okay, F3 and F4. F3 and F4 are equal and opposite. Are equal and opposite. Opposite. They cancel with each other. They cancel with each other. Okay. Now I want the force on AB loop. They will not cancel. Force on AB, force on CD will not cancel because here distance is less, here distance is more. They are also opposite F1, F2, but they will not cancel. Then force on AB loop I want to find out. Force on AB loop. How to find out the force on AB loop? Formula already you know. F1 is equal. Formula is what? Nu naught I1 I2 by 2 pi r. R is the distance between these. A, that one, into L. L is the length of the conductor. Length of AB is AL. L only. AB is, this is L is equal to AB, and B is equal to AD. Okay, right. And now I want the force on one more loop. Force on CD loop. What is the force on CD loop? Force on CD loop is F2. Its formula is again nu naught I1 I2 by 2 pi. Now CD loop distance we have to take from this. Force applied by this conductor on the CD loop, right? Distance is A plus B, 2 pi r. R is A plus B into L, the same length CD. Then these are in opposite direction. That's why net force on ABCD loop. There are 4 forces. Out of the 4 forces, 2 are cancelled and 2 are opposite direction. Right? Net force is equal to, we have to subtract them. That is F1 minus F2. Okay? Or F2 minus F1. What we have to do? Which is more? Here A is less, F1 is more. A plus B is more, F2 is less. Okay? In denominator less is there means F1 is more. Write F1 minus F2. F1 minus F2. Nu naught I1 I2 by 2 pi A into L minus nu naught I1 I2 by 2 pi of A plus B into L. Okay, this is the formula. Right? This is how to find out the force on rectangular loop as shown in figure. Okay, and let us go for the one more application, that is there are 3 parallel loops are there. Okay, some applications I am telling. This is a first conductor. It carries some I1 current. Okay, this is the second conductor. It carries I2 current. This distance is x. And this is the third conductor. It carries I3 current. Okay, there are 3 conductors are there. And now this is A B conductor. This is CD and this is EF. Okay, right. And this distance we will take as y. Then question is that find net force on CD loop, CD wire, on CD wire. We have to find out the net force on CD wire. Then how to find out the net force on CD wire? Right? Then for that, what is the direction of the net force? For example, the CD wire has the length L. CD wire has the length L. Okay? Look at here, net force if you want to find out, these two are in same direction current, then that is attraction force will be there. This AB wire attracts the CD this side, this is F1, and this EF wire also attracts the CD because the current is in same direction. This is F2. The net force I want to find out. Then how to find out the net force? Okay, the net force we have to subtract them. Net force on CD, net force on CD wire, yes, that is F is equal to, we have to subtract them, F1 minus F2 because they are in opposite direction. What is F1? F1 is the force between these two. Its formula is nu naught I1 I2 by 2 pi r, distance between them is x, into L minus F2. F2 is the force between these two, right? And nu naught I1 I2. I1 is not I2. Here I1 become I2, I2 become I3 because currents are I2 I3. By distance between them is y, 2 pi r, r is y. Nu naught I1 I2 by 2 pi r into L. L is length. Length of this one is same. Now we have to simplify this. Net force we will get is, we have to common something. Let nu naught I2 by 2 pi we can common. Nu naught I2L by 2 pi we can common. Then we will get I1 by x minus I3 by y we will get. This is the formula for the net force. And from this, for example, if net force is 0, if CD is in equilibrium, if CD is in equilibrium, equilibrium means what? Force on CD will become 0. Force on CD 0 means this net force is 0. Right? Force on CD only F is 0. What is the condition for F? These two are equal, then F will become 0. Then condition is, what is the condition? Right? I1 by x is equal to I3 by y. Is it right? If these two are equal, then the net force is 0. When net force is 0, this CD will be in equilibrium, means CD will not go to left side, CD will not go to right side. Okay, then the net force will be 0. That means these two forces will be cancelled with each other. Okay, right. And let us go for the one more last application. Take the screenshot and note it. Fifth application is that there is a current carrying wire. Okay, look at here like this. There is a current carrying wire like this. Then some I1 current is flowing through this infinite straight wire. Infinite straight wire, it is fixed at somewhere. And now it carries some I1 current. Above this, some L length wire is suspended. Okay, this is L length wire. It is suspended. This is in air. Okay. Now this wire has weight acts in downward direction. This is mg. Okay. In order to maintain this wire, current carrying wire in air, okay, above, just above this wire, okay, then what is the condition for that? The weight will act downward direction, due to that this wire will be fall down. Okay, this wire not have any support, it is in the air. This is just above this long wire. And now at the moment, what is the condition to maintain this in equilibrium in the air? Right, its weight will act in downward direction. If this wire repels this wire in upward direction, if that repulsion force and this weight balances, means it will not come down. Okay, repulsion force, when it will act, if the current is in opposite direction, right? If the current is in opposite direction, this I1 goes to right side and I2 goes to left side, then they will be repelled with each other. The repulsion force is F. If this repulsion force, upward force, and balances with this weight, then that will be at rest. Now our question, okay, and this is AB wire, and the condition to maintain AB wire in equilibrium, right, at rest in air. Condition to maintain AB wire in equilibrium. Okay, what is the condition to maintain the AB wire in equilibrium? Equilibrium means rest. Rest means under the forces it is at rest. Okay, AB wire is at rest just above long wire, right? Just above long wire. Then for that, the repulsion force, okay, repulsion force, these two are carrying the current in opposite direction, they will repel with each other. That means upward force, that one is equal to weight, okay, weight of this wire. Then upward force is what? Force between these two wires. This we will take as distance. If it is R, then we write as force between them is nu naught I1. this one carrying the I1 current, it carries the I1 current nu naught I1 I2 by 2 pi r into separation between them is r and the length of the wire is L, force on AB wire whose length is L, that is equal to mg. This is the condition, right? If this condition satisfied, then that will be float in the air. Okay, then wire will float in air, right? Then wire will float in air. This is the condition to float the AB wire in air, because the repulsion force acts and the weight will act in downward direction, and if that repulsion force balances with the weight, then it cannot goes up, cannot goes down, means it is at rest in the air just above the this long wire. Okay, right? And note the points. Okay, let us go for the solution of this question. Two long and parallel straight wires A and B. This is a wire and this is the B wire. They are the long and parallel. Okay, and they are carrying the currents 8 ampere and 5 ampere. I1 8 ampere, I2 5 ampere, and in the same direction. They are separated by 4 centimeters. The separation between them is 4 centimeters. What the data they give? Solution: current through first wire 8 ampere, current through second wire 5 ampere. Separation between them is 4 centimeter. 4 into 10 to the power of minus 2 meters. Estimate the force on 10 centimeter cross section of wire A. On the wire A, on 10 centimeter, how much force acts? Force acts on the 10 centimeter length. You can convert this 10 into 10 to the power of minus 2 into meters, 10 power minus 1 meter. Force on wire they are asking. The force formula already we know, nu naught I1 I2 by 2 pi r into L. Substitute all values, we will get easily. 4 pi into 10 to the power of minus 7. I1 is 8, I2 is 5. L is 10 power minus 2, 10 power minus 1 by 2 pi r is 1 meter. R is what? Sorry, R is 4 into 10 to the power of minus 2 meters. 4 into 10 to the power of minus 2. Now we have to simplify this. 2 pi 2 ja, okay, 4 2 ja, 2 2 ja 4, 4 5 ja 20. F is equal 20. Okay, 4 5 ja 20. 10 to the power of minus 7, 10 to the power of minus 1, 10 to the power of minus 8, 10 to the power of minus 2, 10 to the power of minus 6. Okay, and this you will get as answer 2 into 10 to the power of minus 5 Newton. This much force acts. And they are also asking the nature of the force, means whether it is attractive or repulsive. Current is in same direction, means attractive. Force is attractive in nature. Current same direction means attractive. Current's opposite direction means repulsive. Okay, right. Thank you for watching my lectures. Subscribe my channel and share to your friends. Thank you.